here we go. Here we go again, continuing with the cost structure of the firm. So far, we've gone through the idea of what do we mean by fixed cost, what do we mean by variable cost, what do we mean by this concept of average fixed cost and average variable cost, and what do those curves look like. This section, we're going to be going over why do the average variable cost and the average total cost take this U shape, what I called the Nike swoosh symbol before, which most textbooks call it that U shape. Now, I thought it might be good at this point to say, thank you for watching these tutorials, and I really appreciate it because I hope they're helpful to you when it comes to the testing materials and the focus and getting an overview. So thank you very much. I appreciate it. But I thought it might be helpful at this point to just pause a second and ask the question, what's it all about, Alfie? Why are we going through this other than we're learning microeconomics? But why is it important to know about the cost structure of the firm? Is it just something out there that academics want us to know, or is there some good and valid business reason why this is going to help me in my business career making business decisions? So I thought I would just give a quick overview of where we're going and why we're going there by just stepping back a second and just looking at the big picture before we continue on with all the nitty-gritty details of these particular items within the cost structure of the firm. Remember, in the prior section, we were talking about elasticity, price elasticity of demand. And in those sections, we came up with something that we called the revenue maximization rule. So if we're producing a product, it's a new product, we can put whatever price we want on that product. So the question is, what price do we want to put on that product? And if the answer to that question is, well, we want to pick that price that will bring the most revenue into our cash register. If we pick a price of $1 million a piece for this good, we're not going to sell very many and we're not going to make $1 million. But if we have a price of 2 cents for this good, that doesn't cover our costs. We can't make any money at that, so we're not going to make any money at 2 cents and 5 cents. We're not going to make any money at $1 million. And so there's got to be some point between those two prices at which we make more revenue than any other price we can pick. In this case, that part of our text, we are a price maker. As we get into the cost structure of the firm, the first part of that, you're going to see we are a price taker. In other words, we have to take whatever price is the going price in the market for whatever we're producing, because other people produce the same thing. But back in that section on elasticity of demand, we were a price maker. We can pick whatever price we wanted. And we said our revenue maximization rule was that we want to pick that price at which elasticity of demand equals 1, and we'll make more revenue than any other price we can pick. So now we thought, well, okay, we've got revenue. And we said that revenue is really price times quantity equals revenue. And so we've covered that before. Now in this section of the book, we're talking about costs. And so far we've covered fixed cost, variable cost, and today we're going to spend some more, in this section, some more time talking about the sum of those two called total cost. So revenue is the money that comes in, cost is the money goes out, and we really want revenue to be bigger than cost, and if it is, we get something called profit. The jargon is that if this number is greater than 0, it's a profit. If it's less than 0, it's a loss. And so if it's in the profit range, we say we're in the black. If the cost is higher than the revenue, then this is not black. It's usually written in red, and it says we're in the red, or think of it like we're losing blood. We're losing the life of this business. And you cannot lose very much blood for very long and still remain alive. The same way any business cannot have losses very long and still remain alive. So this is where we're going. We've talked about the revenue maximization rule. In this section, talking about cost, we're no longer talking about this. We're really focusing on this section right now, the cost structure of the firm. We're focusing on this so that we can maximize our profit. Point one, we want to maximize our revenue. We want to minimize our costs in order to maximize our profit. That's what it's all about, Alfie. That's why we're going through all this cost structure of the firm. We're trying to figure out how do we maximize our profit. And it's not always intuitive about how to do that. And so that's why we're talking about fixed cost, variable cost, average fixed cost, average variable cost, total cost, average total cost. And we'll talk about something called marginal cost in just a little bit. But this is an overview. We're working on cost because we're really trying to figure out how can we maximize our profit. That was a little introduction there, and now we're going to go back to our main topic of why curves, the average variable cost curve, why does that look like a U, or in my terminology, a Nike swoosh sign? And we said, okay, we've got an average fixed cost curve that looks like that. When we don't produce very many, our average fixed cost is extremely high. We start producing any at all, and that average fixed cost falls like a rock until we hit some point at which it begins to taper off, and after that point it begins to flatten out and go down very, very slowly. And I called this the Palos Park portion of the average fixed cost curve. We said that we also had, and I'll try to put this in maybe a different color, an average variable cost curve. An average variable cost curve, we said, goes down and goes back up like that. We called that the average variable cost curve. Now you might remember, we said that fixed cost plus variable cost equals total cost. Right? And you also learned that what we do to one side of the equation, we have to do to the other side of the equation. So if we divide this side by quantity, we get average fixed cost plus average variable cost equals, well, if we've divided this side by quantity, we have to divide that side by quantity. And when we take the total cost divided by quantity, we get this average total cost. Algebraically, makes great sense. Just like fixed cost plus variable cost equals total cost, in parallel fashion, average fixed cost plus average variable cost gives us average total cost. Algebraically makes sense, but how does that look when we graph it out? So rather than add them together algebraically, what would it look like if we were to add them together graphically? Let's say that this is our origin, and as we increase output along here, our average fixed cost is at the top of the book. But now we want to add to our average fixed cost curve. We want to add an average variable cost curve. So I'm going to take this eraser, and I'm going to set it on top of the average fixed cost. So now I can add my average fixed cost to my average variable cost, and when I come to the very top of the eraser, now I have my total, my average total cost. So this is how I would add them together as a physical model to represent the total height of being my total cost. So now if we go back to this curve here, and I try to do the same thing on this whiteboard as I did here on the table, how would I add those two curves together? And for most students, that's quite a stumper. So let me just point out how we can do that, and we just add some construction lines in here, like this. And what I'm going to do is I'm going to leave my average variable cost curve right there, and I'm going to take this average fixed cost curve. Remember how I took one and set it on top of the other last time? Well, I'm going to take this average fixed cost curve, and I'm going to set it on top of the average variable cost curve. And I'm going to do it like this. I'm going to take this, at this output here, I'm going to take this dimension right here. I'm going to take my finger calipers, and I'm going to lift it, and I'm going to put it on top of my average variable cost curve. See what I did? I just took this dimension, so I'm to my average variable cost curve, I'm going to take my average fixed cost, and I'm just going to add it to by setting it on top of my average variable cost curve. Similar, I'm going to take this dimension here, depending on how close I can keep my fingers, and I'm going to set it on top of the average variable cost curve. Then I'm going to take this dimension here and set it on top of the average variable cost curve. Then I'm going to take this one, which is slightly wider than my finger here, and it's slightly wider, so it's here. Then I take this one, which is about the same, I put it here, and this one, which is about here. And now I can connect the dots. Now notice what I've done. I've taken the dimension, the price, the cost dimension of the average fixed cost curve, and I've simply set it on top of the average variable cost curve. So since it can't be at two places at once, I'm going to erase the average fixed cost, because now I've transferred those values on top of my average variable cost curve. And if I play my connect the dot game again, I get a curve that looks something like that, and I call it my average total cost curve. We did it algebraically. This is how we do it graphically. I'm not going to ask you how to do that on a test or something like that. I just want you to see conceptually how this works. So let's say, for instance, let's go out here to this particular quantity X right there. And we want to know, well, when we produce this quantity, what is our cost per unit? Well, our cost per unit is going to be the summation of our average fixed cost, or our average variable cost, right here. Average variable cost, because that's underneath the variable cost curve. And this dimension here, as we just saw, was our average fixed cost. And we take our average fixed cost, we add it to our average variable cost, and we get this top curve right here, which is called our average total cost curve. It's our average total cost curve. So we could say, well, if you add them together, we get, if I can clean this up just a little bit for you here. I don't know if I'm going to make it worse or better if I mess with it anymore, because I'm not an artist. But we have, again, for the average total cost curve, what we saw for the average variable cost curve. We get this Nike swish symbol, what some texts call the U shape of this curve. As we start out producing, our average total cost per unit is pretty high. And as we increase output, it comes down, it bottoms out, and as we continue to increase output, it begins to go back up again for any fixed size operation. In terms of vocabulary, when we're increasing output and our average total cost is coming down as we increase output, it's costing us less and less per unit as we increase our output. That's called economies of scale. Economies of scale. We can be more competitive when we produce more than if we produce less. But that only lasts for so long. Pretty soon we get up to the point where if this room was our factory, if the orders keep coming in and coming in and coming in, and we keep putting more and more pieces of equipment and packing more and more people into this room, pretty soon we're not at ultimate efficiency. Pretty soon everybody's in each other's way. We don't have room to stock raw material. We don't have room to stock finished goods. We've got to rent used storage buildings, which are not very efficient. And we pass our efficiency point, and as we increase our output past the point of our maximum lowest cost efficiency, as we go up this side of our average total cost curve, that is called diseconomies of scale. So again, we have this U-shaped curve for both the average variable cost curve and the average total cost curve, which has this sort of U-shaped form. If we're on this portion of the curve from here to here, we have economies of scale. If we go further over, we have diseconomies.